Technical requirements of fiber optic cables. Cable construction. Central strength and anti-buckling member. The required cable includes a central strength and anti-buckling member made of 2.5 mm GRP, subject to vendor design. Superabsorbent polymer yarns. These are wrapped around the central member, or superabsorbent polymer binders suitably located elsewhere in the cable structure. Filler rods. Optionally used in lower fiber count cables to keep the structure round. Aramid yarn layer, engineered to provide the required level of tensile strength. Superabsorbent polymer tape, wrapped around the aramid yarn. Ripcords, 1 or 2 ripcords are included. Sheaths, lead inner sheath and HDPE outer sheath, subject to vendor design. Core configuration. General core configuration. The configuration varies based on the specific application and requirements. The vendor shall provide details on the fiber count, tube count, cable diameter, cable weight, and sheath diameter for specific installations. Composition and function. A 2.5 mm GRP rod, subject to vendor design, placed in the center of the optical cable core, serves as both a tensile strength element and an anti-buckling member. It must be free of imperfections and stiff enough to prevent kinking at the minimum bend radius. Buffer tubes and filler rods. Construction. The cable must be of stranded, loose buffer construction where fibers are contained in a series of tubes. Thixotropic gel. Inside the tubes, filled with a thixotropic gel to prevent moisture ingress. This compound must be non-toxic, dermatologically safe, free from foreign matter, chemically and mechanically compatible with all cable components, non-nutritive to fungus, non-hygroscopic, and electrically non-conductive. Color coding. Each buffer tube is distinguishable by color coding as per EIA TI 590HA. Optical fibers. Specifications must meet ITUT recommendation G655 and detailed specifications provided. Each cable must have traceability of the optical fiber back to the original fiber ID number and test parameters. Core construction. Design. The central fiber optic unit consists of core of loose buffer tubes around a 2.5 mm subject to vendor design, GRP anti-buckling and strength member. Superabsorbent polymer materials. Water blocking. Cables must be water blocked with superabsorbent polymer water blocking yarns, tapes, and/or binders. Superabsorbent coatings on cable elements are not acceptable. The materials must be safe, easy to remove, and require no special handling or solvents. Strength yarns. Material. The strength yarns for polyethylene sheath cables shall be aramid yarns. Outer sheath. Composition. The sheath shall consist of a tough, weather-resistant, high-density polyethylene HDPE, hydrocarbon-resistant PVC. Quality. It shall be circular, free from pinholes, joints, mended places, and other defects. Jacket thickness measurement and eccentricity standards apply. Optical fiber identification. Color coding. Each fiber in a tube must be distinguishable from other fibers in the same tube by means of color coding ink discernible throughout the design life of the cable as per EIA TI 598A. Outer sheath identification. Marking. The outer sheath shall be marked with the manufacturer's name, fiber count, standard code, week and year of fabrication, progressive metric marker, customer name, project name, and project contractors. The letters shall be clearly printed by means of non-metallic paint. These requirements ensure the high performance, reliability, and durability of the fiber optic cables used in the project, aligning with international standards and project specifications. Cable performance requirements, mechanical characteristics. Nominal cable diameter, vendor to provide. Nominal cable weight per kilometers, vendor to provide. Minimum bend radius during installation, 20 bias cable outside diameter, vendor to confirm. Minimum bend radius after laying, 10 dikes cable outside diameter, vendor to confirm. Compressive load, vendor to provide. Impact load, vendor to provide. Optical performance of cable for G655 single mode fibers. Attenuation variation with wavelength 1550 meters, 0.2 dB kilometers. Induced attenuation at 1550 nanometer due to water immersion at 23-2 skis, 0.05 d kilometers. Attenuation with bending, 100 turns on a 60 mm mandrel diameter, 0.55 d at 1550 nanometers. Maximum non-cabled fiber attenuation coefficient loss, at 1550 nanometer to 0.2 dB per kilometer. Optical point discontinuities at 1550 nanometer 0.05 dB. Chromatic dispersion at 1550 nanometers, both 2.6 to 6 ps per nanometers kilometer. PMD coefficient, 0.2 px per kilometer. Environmental performance of cable, operating temperature, as per section 4.2. Allowable change in attenuation at temperature extremes, 0.58 dB per kilometer. Installation temperature, as per section 4.2, storage temperature, 10 to plus 85 degrees Celsius. Fiber geometry and performance requirements for G655 single-mode fiber. Fiber type, G655, compliant single-mode fiber, 9 and 125 mm. Mode field diameter at 50 nanometer, 8.4 per 0.6 mm. Clad concentricity error, 2.5 mm. Cladding diameter, 125 bis 1 mm. Cladding circularity error, 1%. Coating diameter, 245 minus 10 mm. Proof test level, 0.7 GPa, 100 K por psi. These requirements ensure that the fiber optic cables meet the necessary mechanical, optical, and environmental performance standards for reliable operation in the specified conditions. Testing requirements. General. Provide test reports for the IEC 60794-1 series of cable tests noted below. The tests must have been performed on an identical or similar construction to the one being offered, and with equal or higher fiber count. In the absence of pre-existing test reports, the cable vendor must perform the tests on an actual length of cable manufactured and shall submit the type test reports to the purchaser for approval. Water penetration. A sample of cable must be tested for water penetration to IEC 60791-F5B with a 1 meter head of pressure for a period of 24 hours. The water pressure shall be applied to the cut end of the cable in an L-test configuration. Crush resistance, compressive strength. The test shall be performed per IEC 60794-1E3 according to the compressive load requirements. After release of the compressive load, an average increase in optical attenuation greater than 0.1 dB at 1550 nanometers shall constitute a failure for FOC installed in HDPE conduit. Impact resistance. The test shall be performed per IEC 67941E4 according to the impact load requirements shown above. After impact, a permanent or temporary average increase in optical attenuation value greater than 0.1 dB at 1550 nanometers shall constitute a failure for FOC installed in HDPE conduit. The cable jacket and armor shall not exhibit evidence of cracking or splitting. Compound flow test. The test shall be performed per IEC 607931B1 according to the compound flow test requirements. No drip shall occur at 70 degrees Celsius. Repeated bending. The cable must be subjected to a bending radius of 20 times the diameter of the cable for 6 complete turns, according to IEC 60794-1E11-E6 test methods. During or after bending, a permanent or temporary average increase in optical attenuation value greater than 0.1 dB at 1550 nanometers shall constitute failure. Stress strain, tensile load. The test must be carried out in accordance with IEC 60794-1E1 to determine the tensile characteristics of the cable under load and to verify the fiber strain margin within the cable. The maximum change in the optical attenuation at the cable's rated maximum working tension shall be no greater than 0.1 dB at 1550 nanometers for FOC installed in HDPE conduit. Thermal cycling. The cable shall be tested to determine the temperature dependence of attenuation. The test shall be performed according to IEC 60794-1F1. The optical fibers shall maintain mechanical and optical integrity when exposed to operational temperature extremes of minus 20 degrees Celsius to plus 70 degrees Celsius. The attenuation variation with respect to ambient temperature shall be less than 0.05 dB per kilometer at 1550 nanometers. Jacket adhesion strength. The jacket adhesion test shall be performed according to IEC 607081-19.2. 4 test samples shall be taken on the overlap region shifted 90 degrees from each other. It shall not exceed 1.8 nanometers. Torsion cable twists. The cable must be subjected to 10 twists of 180 degrees on a 1 meter cable sample, according to IEC 60794-1C7. A permanent or temporary average increase in optical attenuation value greater than 0.1 D at 1550 nanometers shall constitute failure. Inspection and tests. General. During manufacture, the purchaser or its appointed delegate might visit the manufacturer's shop to verify that the cable meets the construction rules, drawings, and specifications. This inspection is paid for by the purchaser. Inspection procedures are to be agreed upon by the vendor and the purchaser. The vendor shall inform the purchaser of the specified dates well in advance, not less than 4 weeks before the inspection date. Dimensional test. Vendor responsibility. The vendor shall carry out tests on incoming goods to verify the integrity of the materials manufactured. Tube dimension. Measurements for inner and outer diameters with a tolerance of ±10%. Sheath thickness. Nominal and average measurements with a tolerance of ±10%. Outer diameter. Minimum and nominal measurements with a tolerance of +10%. Frequency. Dimensions shall also be tested randomly on one cable length during the manufacturing process. Acceptance tests. Final inspection. The acceptance tests shall include optical time domain reflectometry (OTDR) measurement, testing length and attenuation for each testing length. For runs over 100 meters, the test shall be made at both ends and the two measurements compared. Differences greater than the instrument resolution shall be investigated and resolved. Attenuation measurement. Ensure compliance with the design specification. Graphic summary, backscattering diagram, used for localized losses detection during installation. Specific tests carried out by the vendor shall include attenuation measurements for each fiber in dB kilometers, average and maximum, in all cable lengths of the supplied lot. Backscattering diagrams. General inspection, ensuring construction conformance. Fiber-specific tests, attenuation coefficient for 1550 nanometers, non-zero chromatic dispersion slope, chromatic dispersion at 1550 nanometers. The contractor shall also submit all certifications relevant to the type tests as listed in the section for the origin of the fibers and completed cable. Drum tests shall be done on-site before laying the cables. Special tests. The supplier shall demonstrate that the following type tests were performed on the fiber optic production process to guarantee quality. If the supplier has different tests or categories, they will be evaluated by the purchaser or its representatives. Tensile breaking strength on a long sample can be given in the suitable distribution form. Bending, Ref IEC 793-1, Method XXB3. Stress corrosion susceptibility, Factor N, Ref British Telecom CW 1500, Item 3.7. Dynamic strength, British Telecom CW 1500, Item 3.9. Abrasion, REFA IEC 793-1, Method XXB-4. Microbending sensitivity, test to evaluate performance under microbending conditions. These inspections and tests ensure the fiber optic cables meet the necessary specifications and quality standards for reliable performance in their intended applications. General. The fiber optic cable conduit shall be laid in the same trench as the oil pipeline, positioned at the 2 o'clock position. The installation method must ensure all cable installation requirements are met, adhering to the highest standards of quality and craftsmanship in the communication industry, ensuring electrical and mechanical integrity of the connections. Manufacturer's installation procedures. Follow the manufacturer's recommended procedures at all times. Handling and storage. Avoid standing on the cable, and do not allow vehicles to drive over it. Cable drums should be rolled only in the direction indicated by the arrow on the drum, and should not be laid flat. When lifting the cable drum, use a spreader bar to avoid inward pressure on the drum flanges. Ensure cable ends are sealed with a heat-resistant sleeve to prevent moisture ingress. Pre-installation testing. Test the cable at the site before starting the laying process, and record the test results in the approved test sheet format. Mandatory slack. Slack for future movements. Provide sufficient slack for future cable movements wherever the FOC is spliced or terminated. At block valve stations or splicing boxes, coil 10 meters of slack on each cable section. Inside racks, route the cable up to the ceiling and back down before terminating, tying it orderly to the rack. Trench laying. Allow sufficient slack to account for normal soil movements without putting unnecessary stress on the cable. Splicing chamber and splicing boxes. Provision and installation. Provide splicing chambers where required to house the splicing box and overall cable length. Install splicing boxes and marker posts for the chamber. Splicing chambers should protect the splicing box and be installed underground. Ensure splicing enclosures are rated for service in manholes, designed to prevent water and vermin ingress, and suitable for continuous submersion in water up to 5 meters deep, IP68 rating or equivalent. Splicing enclosure features must have a guaranteed operational life of 40 years, be physically supported or wall-mounted in manholes, and equipped with fiber management and protection components. Use mechanical sleeves for all fusion splices, organizing them in a splice tray within the enclosure. Enclosures must include cable hold-down mechanisms, strain relief, and adjustable, reusable cable gland devices to seal against moisture, water, and vermin ingress. Termination. Responsibilities. Contractor is responsible for termination testing up to patch panels, providing 10 meters of slack where FOC has to be terminated. Termination process. Use fusion splicing for the pigtails and bare fibers from the FOC, organizing and securing the loose fiber well in the splice tray. Route each subsequent section end inside a splicing chamber, leave it as a loop of cable, seal, and secure it with sufficient excess cable for splicing at joint locations along the pipeline route. Ensure sufficient length at cable ends to allow termination within the facility, coiled and protected with ends identified and sealed. FOC splicing. Splice method. Use fusion splicers only. Mechanical splices are not allowed. Splice all cores of the cable at each joining location, whether in use or spare. Protect splices along the cable route with re-enterable and reusable splice enclosures. Splice enclosure identification. Each splice enclosure must be uniquely tagged for identification. Testing and personnel. Test all splices for mechanical integrity and optical performance, ensuring each splice has less than 0.1 dB of insertion loss. Perform end-to-end OTDR tests to confirm splice loss. Only trained, authorized personnel should perform splicing. Splicing environment. Conduct splicing in an air-conditioned, dust-free controlled environment. Use core alignment fusion splicers and semi-automatic cleavers for precise cuts. Protect fiber optic splices with mechanical sleeves, inserting them into the splice closure's cassette, then carefully closing the closure. After splicing and testing, clean and close the chamber. These procedures ensure the proper installation and protection of fiber optic cables, maintaining high standards for future reliability and performance. Civil Works. HDPE Cable Conduit Routing Plan. Pre-construction survey. The contractor shall perform a pre-construction survey along the planned cable conduit route to identify and accurately locate all existing third-party facilities above and below ground to the satisfaction of the company. Routing plan preparation. Prior to conduit installation, the contractor shall prepare a routing plan used in conjunction with the approved pipeline alignment sheets and drawings. This plan will list manhole location splicing chambers, conduit installation types, e.g. open cut road, weighty crossings, board crossings, and HDD, conduit coupling locations. Documentation. The contractor shall prepare and issue all required documentation for obtaining any approvals and permits from authorities and/or third-party operators, company's supervision and monitoring of the work, staking and marking the site, including temporary and permanent markers. Trenching. Excavation equipment. Only light and approved excavation equipment is allowed for the excavation of the cable conduit trench. The contractor shall obtain approval of the excavation methodology as part of the conduit installation procedure. Minimum depth of cover. The minimum depth of cover shall be as follows. Normal terrain, 1.0 meters. Hard rock area, 0.8 meters. Minor road track livestock passage. Crossing, 1.5 meters. Highway major road crossing, trenchless technique, 3D, where D is pipeline diameter. Wadi crossing, 2.5 meters. Highway road crossings, open cut, 2.0 meters. The trench shall be backfilled with soft sand and compacted till the depth where the FOC has to be laid. HDPE conduit materials, material handling and storage. The 1,000-meter HDPE conduit reels or palletized coils and conduit joining kits shall be supplied and stored adequately above ground to avoid damage, degradation, or contamination. All manufacturing documentation and certificates shall be held by the contractor's quality department. Proximity to installation site. HDPE conduit coils shall be stored, handled, transported, and placed in close proximity to the installation site. Conduit joining shall be carried out in accordance with the manufacturer's recommendations. Manholes, jointing pits. Installation locations. Manholes shall be installed for each fiber optic cable splice at the required locations. Manholes shall be manufactured and sealed, grouted in accordance with specifications and drawings. Cover depth requirements. Normal terrain, 1.0 meters. Hard rock area, 0.8 meters. Minor road, track, livestock passage crossing, 1.5 meters. Highway major road crossing, trenchless technique, 3D. Whitey crossing, 2.5 meters. Highway road crossings, open cut, 2.0 meters. The bend radius compliance. The bend radius of HDPE cable conduits when entering and exiting each manhole will comply with the specification requirements. HDPE conduit bends shall not be made within 2,000 millimeters on either side of a conduit splice. Jointing pit installation. A cable jointing pit shall be installed at 4 or 6 kilometer distances along the pipeline, depending on the lengths of the cable on each drum. The cable jointing pits may be the same as the cable access pits used to blow the cable during installation. Buoyancy control. Buoyancy measures, buoyancy control measures, e.g., sandbags, set on weights, shall be considered to ensure negative buoyancy is maintained for the conduits without fiber optic cables installed. Buoyancy control methods of installation shall be subject to company approval. HDPE conduit jointing requirements. Joining process. The contractor shall provide continuous cable conduit joints required at least at each end of the supplied conduit section. For critical areas, it may also be necessary to reduce the length of the conduit section to be jointed due to local criteria, such as topography and crossings. Manufacturer's instructions. The contractor shall follow the conduit coupling manufacturer's instructions for the preparation of the joints and the selection of tools. The conduit ends shall be inspected, and only if no scratches or any other damage is found can the conduit ends be jointed. Cleaning. The contractor shall clean the conduit sections before joining them. Markers. Installation of markers. Cable route markers shall be installed upon completion of the cable installation and generally after the cable trench has been backfilled and compacted. Pipeline markers positioned along the route, including various crossings and direction changes, shall also include cable identification as approved. Marker specifications. The markers shall be made from aluminum with a width of 100 millimeters, height of 30 millimeters, and thickness of 1 millimeters. The text shall be engraved on the aluminum marker, providing details of the FOC type, route, manhole number, start, and end locations. Jointing pit markers. All joining pit locations shall be marked for proper identification by installing pit marker signs. Fiber optic cable tests. General. All type tests and routine tests shall be carried out as per the relevant standards, and all certificates and test results shall be made available for evaluation and acceptance. The contractor shall provide the testing and calibration equipment necessary to test, calibrate, service, and generally maintain the system equipment to its maximum reliability and accuracy. The company reserves the right to witness all the tests and must be notified at least 20 days in advance of when such tests are to take place. Fiber optic cable tests. The contractor shall develop complete procedures for the splicing tests, fiber optic tests, etc. Each fiber optic cable shall be tested for integrity, and a test report shall be issued, providing figures of fiber attenuation and remaining fiber optic budget margin. This report shall be signed off by the contractor and company. Optical test and fusion splicing equipment. One automatic fiber optic fusion splicer, OTDR, and light source or power meter test set shall be provided as defined herein. OTDR shall be utilized for pre-installation and installation work. All such optical equipment shall be in fully operable condition without defects and shall be calibrated as defined by the manufacturer's recommendations. OTDR typical requirements. A recording optical time domain reflectometer, OTDR, will be utilized to test for end-to-end continuity and attenuation of each optical fiber. The OTDR must be equipped with data storage, printer, help feature, compare trace features, and OTDR software. Data traces labels. Fiber identification, ID, with a minimum of 10 characters. Cable ID with a minimum of 10 characters. OTDR location with a minimum of 20 characters. Far end location with a minimum of 20 characters. Test operator initials with a minimum of 3 characters. Printer, preferably internal, capable of printing data traces within 30 seconds or less. Machine settings include index, range, wavelength, average time, pulse width, and scale settings. Test results should include loss, distance, reflectance, date, and time. Compare trace feature, ability to recall 2 historical traces from a diskette, display them simultaneously for analysis, and compute display differences. Must perform a 2-point loss measurement test for any 2 particular fibers in comparison analysis. If connectors exist in the cable under test, then 2 traces shall be recorded. 1 trace for the fiber loss dB, an average attenuation, dB per kilometers, of the entire cable segment, including connectors. The second trace for a magnified view of the connector regions, revealing connector losses, dB. HDPE conduit installation test, general. After refilling trenches, the contractor shall perform section-wise pressure and calibration tests for sections of at least 1,000 meters in length. Any damages or deformations hindering the blowing of the fiber optic cable shall be repaired by the contractor, and the tests repeated for the repaired section. Pressure tests. Blow through the conduit with compressed air to clear any debris. A lightweight mandrel dolly, foam, plastic, or rubber, similar to the one used for shooting in the FOC, shall be blown through the conduit to confirm it is free of water, debris, and obstructions. The pressure test shall confirm the conduit is airtight and waterproof, performed with at least 10 bar air, and no pressure drops allowed after temperature equalization for 30 minutes. The pressure drop shall be measured by a calibrated pressure recorder. Fiber optic cable installation test. General. All cable types shall have been subjected to type tests according to relevant standards. A drum test shall be carried out prior to unrolling to ensure the cable has arrived undamaged. Installation tests shall verify cable quality before splicing. After each splice, tests shall confirm workmanship quality before sealing the splice enclosure. After all splices are complete, overall end-to-end parameters shall be measured. Tests to include optical fiber cable attenuation per kilometer, splice attenuation, acceptable test result data, fusion splice attenuation 0.1 dB. For the whole cable loop, including connectors at both ends, 90% of splices shall show an attenuation of less than 0.15 dBs. FO tests instruments, optical time domain reflectometers, calibrated laser source and power meters, appropriately fitted connectors ready for use. OTDR selection, based on fiber optic specifications and requirements, with considerations for dynamic range, resolution, minimum operating distance. A calibration test certificate not older than 1 year for the OTDR and power meter. Performance tests. General. After installation completion, performance tests shall verify all FOC links. Tests to include FOC links attenuation, optical time domain reflectometer, OTDR traces showing peak reflections not saturated, and the fiber baselines.